Good morning. This is the final exam review for Algebra 1-1, Units 3-5. On this review, I want to make sure that you're just reviewing how we go through testing and we read the test questions, and that you're not trying to gain understanding of the topic. If you're trying to gain understanding of the topic, then you need to really go into the notes for this unit, and you'll find them under Algebra 1-1, or Algebra 1, Semester 1, Unit 3. And you should go into those notes and take notes on the topic. This is more just preparing you for the test. So when we open the study guide, these are similar questions to what you could see on the test. A lot of this is graphing, and let's get going right into it. A line is graphed on a coordinate plane and has a slope of 2. Remember, our slopes are always rise, never fall, and it would be a rise of 2 over a run of 1. Now, since it's positive, remember positive in math always goes to the right, so it'll rise 2 and then run 1 to the right. It contains the point 3, 1. So let's go to 3, 1, and remember, this is your x, this is your y, alphabetical order. This is x, and this is y. So we go to 3 on the x. It's just like that game Battleship. Go over to 3, go up to 1, put a dot. Now from that dot, count your slope, rise 2, run 1 to the right, and that will be, sorry, I forgot to get a ruler. Let me grab that real quick. That will be your line that you're looking at, and I always say graph, graph, graph when they're talking about lines, even if you have to grab a piece of graph paper as scratch paper to graph with, or make graph paper out of your scratch paper. Always graph. Now it says, which of the following points will be on the same line? -3, -5. Again, that's x, that's y. So we go to -3, -5. That's not on the line, we can mark it out. -3, -2. That's not on the line. 0, -5. Ah, there we go. You don't need to mark out the other one or show where it's at. You've shown with all your work here exactly what you're looking at. Okay, given the graph and the equation, which has a larger slope. Slope, remember, is our rise over run. In this format, we would get the y alone, get y equals mx plus b, and that m will be our slope value. So in order to do that, we draw the line, circle our creepy dude, we subtract 3x. The reason we subtract is because we're going up the PIMDAs, and the first thing we look at is what's being added or subtracted to the creepy dude, or the spotlight. It's a 3x, so we subtract it to get rid of it. We have a -y equals -3x plus 12. Now, remember that we can't combine the 3x and 12 any closer than that. They aren't like terms. Please go to, sorry, I went off camera a little bit. I've got to watch this closer. Please remember and go to the notes on this and go to my topic notes on using tiles for this if you're having trouble with that. Okay, next, we need to get rid of this negative. It is a -1. It's being multiplied, so we divide by -1. Y equals, distribute the -1 under each of those. So it would be a 3x minus 12. Now, 3 is your slope. So it's a slope of 3 over 1. They're wanting us to compare that with the slope of this line. Here is where it's crossing a point, and it crosses a point there. So you can literally count the slope from this point to this point. It's rising 1, 2, 3, 4, and it's running 1 to the right. So it's a slope of 4 over 1. Okay, so if you look at those two slopes, A has the larger slope. So that would be choice A. On number 33, a student graphed a line, 6x plus y equals 8. If she substitutes 3 in for the number 8 in the equation, how will the graph of the line change? Well, I would say we can look at it on a graph, or we can look at it in slope-intercept form. So let's go ahead and get it in slope-intercept form. We just move that 6x across. We'd have negative 6x plus 8. Now, if she substitute 3 in, then we would have y equals negative 6x plus 3. Question is, what is that on the graph? If you've been graphing in my class, then you know we covered this term by the x, and we always say y equals that, and that's where we put the dot to start our graph. So this is your y-intercept. So the line will shift up 5. Well, we've moved from 8 to 3, so it's definitely not going up 5. The graph of the line will shift down 5. That's the one that we want. Okay? Next problem. A student graphed the line 4x minus y equals 2. If he substitutes 6 in for the number 4, how will the graph of the line change? Well, let's take this. We have 4x minus y equals 2. Get it into slope-intercept form. I'm not going to step through every step again. You bring the 4x across. That would make it a negative 4x plus 2. Then divide by negative 1. Distribute it. Y equals 4x minus 2. Now, if we substitute 6 in for that 4, thinking about slope-intercept form, we have the same y-intercept, but what we've changed is our slope. Our slope's gotten a lot steeper with 6, hasn't it? So we look over here, the graph, it won't be shifting up or down. This is when it gets more steep or less steep, and we get more steep because it's going up more squares than it was before, so it's getting more steep, not less. Okay, next graph here. Which is the graph of 2x minus 3? Well, it's got to have the y-intercept of negative 3. So let's go down here. This has a y-intercept of negative 2. It's out. This has a y-intercept of a positive something. It's out. This one has a y-intercept of negative 3. So it might be good. This one, y-intercept of positive 2, it's out. So D is our answer choice. You didn't even need to count the slope. Okay. Next problem here. Which is the graph of, and they give something that's not quite in slope-intercept form. So I would switch it to slope-intercept form, get this y by itself. In order to do that, you'd subtract 20 from each side. So we'd have 5x minus 20. I'm going to bring the 4y to this side now. Divide by 4. And we have y equals 5/4 x minus 5. So we need to have a y-intercept of negative 5. This one has a y-intercept of positive 5. It's out. This one has a y-intercept of positive 5. It's out. These two have y-intercepts of negative 5, so it's a matter of counting the slope. The slope is that it's going to rise 5, run 4 to the right because it's positive. So we rise 5, 1, 2, 3, 4, 5, run 4, 1, 2, 3, 4. This is our line. This one, it rises 4 and runs 5, so it's got a backward slope on it. Next problem here. Which of the following properly describes the line through the points 6, 1 and negative 4, 6? And it's talking about how it slants. So I would immediately grab some graph paper, and I would actually go through and just graph those 2 points. Again, it was 6, 1, 1, 2, 3, 4, 5, 6, 1, and negative 4, 1, 2, 3, 4, positive 6, 1, 2, 3, 4, 5, 6. Okay, so how does that line look? If we look at our options, it says it slants upward at a rate of 2 and crosses the x-axis at 4. Well, we can see we don't even have it crossing the x-axis right now. So A is out. Let me see if I can squeeze this in here so you can see the line in the options. So A is out, it's not crossing the x-axis. The line slants upward at a rate of 1/2. Upward means that it's going up as we go left to right. So that's incorrect. The upward on both of those could be circled. Here we go, the line slants downward at a rate of -2. Now it would be -2/1. Does it drop at a rate of 2/1? No, that would be right here. So that one's out. The line slants downward at a rate of -1/2. That means it drops 1 and runs 2, which is exactly what it does. So D is our correct option. Okay, next problem. Which equation of the line has a slope of 3 and passes through -4, -3? Okay, so I would again graph this. See if I can get it in my camera just right. Okay, so I would graph this. I'd go to -4, -3, 1, 2, 3, 4, 1, 2, 3. Sorry, I'm getting off. Okay, 1, 2, 3. And it has a slope of 3/1, so we rise 3, run 1. Let's go ahead and always use a ruler. There's our line. Now it's in slope-intercept form, and we see on this one, these two, they've got negative slopes. Well, it rises to the right with a positive slope, so those are out. On these two, it has on option C, intersection of -15. And we're way up here at +9, or close to +9. So we know that that one's out for the intercept. That would make this our best choice. Okay. We have just a few more problems to go, about 6 problems. And so hang with me here. Which equation of the line passes through the point 3/2, 5, and -1/2, 8. Okay, and if you look here, they're putting it into more of a point slope format. So the first thing that I would do, you could plug these points in and see which one comes out true. That might be the option that you want to try. I know it's going to bother you to have fractions in there, but don't let fractions really become the annoyance here. Our other option is to find the slope, which I'm inclined to do. I like formulas, so I'm going to do that. So slope is equal to y2 minus y1 over x2 minus x1. So we take the y, put it over the x. Don't worry that that's a complex fraction. We'll get over it here in a minute. Minus, now y1, 8 over -1/2. So you've got 2 negatives together there. That could make a positive. 3/2 and 1/2 is 4/2. 4/2 reduces to 2, so that came out pretty nice. And then 5 minus 8 is -3. So we can go up to our slopes. The slope is this number right in front of the x. No matter what format, it's always attached in front of the x. There's only C and D that have negative slopes, so we mark these out on account of their slopes. And we look at C and D. Now, looking at C and D, what we've got here is a point slope form. So let's go ahead and use point slope. Y minus y1 equals m, which we know is negative 3/2, times x minus x1. Have that formula handy. Now we can simply plug in our values. Let's go ahead and use this one to see how it works out. Y minus 8 equals negative 3/2 x minus a negative 1/2, which would be plus half, and now we need to get the y by itself, because that's how this is with the f of x. So we'll add 8 to each side. And here we have y equals negative 3/2 x plus 1/2 plus 8. And you can see we've got the exact same thing as what this problem here does. Okay? So that would be the correct thing. This one, if you happen to solve it with it, you would have come out with a -5 right there. And that's what would have been wrong. If you didn't solve it, if you just went for this one like I did, then it's fine just to leave this much work and show what you got. Okay, a linear function passes through these 2 points, a second function represented by the equation 4x minus 3y equals 6. What is the y-intercept of the function with the greater rate of change? I would actually graph these again. So let's go over to our graph. Again, guys, I can't emphasize enough how important it is just to go to a graph sometimes. So we have the point 10, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5. There it is. And negative 15, 5. This one will be hard to show on my camera shot. Let me get it out there a little bit more. Okay, negative 15, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Negative 5. 1, 2, 3, 4, 5. So we have got this line. Now realize with graphing, it's an estimate. So at least we'll be able to see which line has the greater slope here. And we'll hopefully be able to answer the question. On 4x minus 3y equals 6, get it into slope-intercept form. So we get rid of the 4x, we have a negative 3y equals negative 4x, because you subtract it from each side, plus 6, divide by negative 3, and we get y equals, negative over negative is positive, 4/3 x minus 2. So go to negative 2, and we rise 4, run 3. That one's definitely going to have the steeper slope, which is also referred to as the greater rate of change. We've talked about that in class. So this is the equation with the steeper slope, and it says, what is the y-intercept? It would be option A at negative 2. And you can just show me the graph. You don't need to do any other work to show what's wrong with these others. Okay, which piecewise function is represented by this graph? First thing that I say is go to your windows. You can see that this window is at positive 1, and the x is less than, that's the arrow tip showing, and it's also equal to because of the solid circle. This other one is at positive 1 as well, but the graph's going that way, so it's that x is greater than. Now it's not equal to because it's an open circle. So the first thing I say is go to the windows and see which ones you can eliminate right now. Very first one, x is less than, it doesn't say equal to, so that one's out. X is less than or equal to, that one works. Hope you can see that's a positive one. Okay, Less than or equal to and greater than, so that one works. Less than or equal to, they have greater than or equal to. So that one's out. And here they have less than and not less than or equal to. So that one's out. You've got your answer just by elimination. Remember, you need to know how to do the math, but I am teaching you the test-taking skills. At this point, we have 5 more problems. We'll be finished here in just a minute. Let's go ahead and look at this piecewise. Again, I go to the window first. This is at a positive 2, count over to it, and your x is less than. It's not equal to it because of the open circle. Okay, well, we do have one here that says x is less than 2, so this could be appropriate. Let's go to the other line. This one is x is greater than, because it's a solid circle, greater than or equal to 0. We don't have a 0 up there, so that causes that one to be eliminated. Next one, we see that they're both at 2 on this one. This one is x is less than 2 with an open circle. This one is x is greater than or equal to 2. So that could be a potential answer. Go down to the next one. They're both at 2 as well. This one, however, says x is greater than 2 without an equals because it's open circle. That would create it to be out. Cause it to be out. Okay, this one we have x is less than 0. We don't have zeros up there, so that one's out. Again, you've eliminated everything to your right answer. And I want to emphasize, I really want you to know the math skills, but at the same time, I want you to take tests well and eliminate. In math, it's huge to eliminate. Jim bought a cell phone plan that will cost him $25 a month, plus 10 cents for every text. That's our slope. Remember, when we have a rate, that's our slope. So it's 0.10 x plus the 25 a month equals our line. We've done a lot of these real-world problems in class, so hopefully as soon as you see that rate, you know, that's my slope, my rate of change. Anything extra is your y-intercept, what you start with. You can see easily B is your answer. We've got a minus here. Here, we've got the wrong slope. We've got 1 attached to our x. And here we have the incorrect slope. Okay? Look closely at your other answer options because sometimes you might not see a negative, so you want to know what's wrong with the wrong ones. Okay. When traveling for work, a salesperson is reimbursed expenses according to the following rules: 50 cents per mile driven, $40 per day for meals. For a reimbursement of $1,000 or greater, a district manager must approve the request for reimbursement. Determine the maximum number of miles a salesperson can travel in 5 days without getting approval from a district manager. Well, if we're gone for 5 days, then we know that we've got 5 days worth of meals, correct? So we'd take 40 times 5, we have 200. So that would be kind of like our y-intercept. We just add the 200 to this 0.5 or 50 cents a mile. Remember, 0.5 is the same thing as 0.50. And we need to stay less than or equal to $1,000. All you need to do is solve it from there. Subtract 200 from each side. Going up your PIMDAs, even though I didn't write the PIMDAs, 0.5m is less than or equal to 800. Divide by 0.5. Divide by 0.5. Here is the tricky part. Remember, you're not dividing by 2. Actually plug that into a calculator. It's asking how many halves are in 800. It would come out at 1,600, so it has to be less than 1,600. Okay? Last 2 problems. I guess I could zoom in a little bit more. Hopefully you're on a machine where you're able to zoom in, or it's a bigger screen so that you can see these. The First 5 terms of the sequence are below: 29, 25, 21, 17, 13. Which equation describes the nth term of the sequence? So we're basically looking for a slope again. Go back to your t-chart if that's easier to you. But our slope is how much we rise or fall from one point to the next. We are falling by a -4, -4, -4, -4. So all the positive slopes we can get rid of. Now these are both at a -4. This other number is your y-intercept, which is when x is equal to 0, or you're at your 0th term. So we just come backwards. And we say, what would we subtract 4 from to get 29? 33. That gives us our answer. This one's out because of the 23. Okay, very last problem. An exercise program begins the first week with 30 minutes of daily exercise. Each week, the daily exercise is increased 5 minutes. Which function represents the number of minutes of daily exercise in the nth week? Okay. I think it's easiest to just do a t-chart of this and say, okay, it begins the first week with week 1 with 30 minutes of exercise. Each week, the daily exercise increases. So week 1, it was 30. Week 2, it'll be 35. Because you're going to take the 30 plus 5. Maybe I should do that. Week 3, you would be going 30 plus 5 times 2. Week 4, 30 plus 5 times 3. Okay, that should give us enough. Now we all see that our first term is 30. So we're all good with that. That's what f of 1 means. We're looking at a recursive here, aren't we? So our next thing is to look at what we've done from the previous term. From recursive, you know that that means previous term right there. You could almost get it just off of that. But what they're saying is that you're adding 5 to your previous term. Go back to recursive sequences. You could do it from your warm-up exercises or in the Unit 3 notes. So that is key right there in the recursive. So that is our answer option. You could also plug in your answers here. 2 is equal to 35 minutes. 3 is equal to 40 minutes. And 45 minutes. You could plug in this 1, 2, or 3 for your n value and see if you get your resulting value. Okay, you guys have a great day, and thank you for tuning in. Good luck studying for this.